Hello, my awesome darling, and welcome back to Hamilton channel. Today, we're diving into a topic that sounds like something out of a sci-fi movie, heavy water. You might be thinking, what on earth is that? Is it just water that's like really heavy? Well, you're not wrong, but there's so much more to it. To understand heavy water, we need to talk about atoms. Regular water, or H2O, is made of 2 hydrogen atoms and 1 oxygen atom. But heavy water, written as D2O, is different. It uses a special kind of hydrogen called deuterium. While a normal hydrogen atom has just 1 proton, deuterium has an extra neutron in its nucleus. That extra neutron gives it more mass, making it about twice as heavy as regular hydrogen. So, heavy water is a molecule where the regular hydrogen is replaced by this heavier version. It's about 10% denser than regular water. If you had a glass of regular water and a glass of heavy water, the heavy water would feel just a little bit heavier. Heavy water isn't some rare man-made thing. It actually exists in nature, but it's super rare. For every 7,000 hydrogen atoms in normal water, only about 1 is a deuterium atom. So you're probably drinking a tiny bit of heavy water right now without even knowing it. Because it's so rare, scientists have to produce it for specific uses. One of the main ways is through electrolysis, which uses electricity to separate water into hydrogen and oxygen. The heavier deuterium atoms tend to stay behind, allowing them to be collected. So why do we even need this stuff? Its unique properties make it incredibly useful, especially in the world of nuclear science. Nuclear reactors. This is heavy water's most famous job. In some nuclear reactors, like the CANDU reactor, heavy water is used as a moderator and a coolant. The moderator's job is to slow down the neutrons released during nuclear fission. This is super important because slow-moving neutrons are much more likely to hit other atoms and continue the chain reaction. Heavy water is great at this because it slows down the neutrons without absorbing too many of them, which means these reactors can use cheaper, natural uranium as fuel. It also helps cool down the reactor to prevent it from overheating. Scientific research. Beyond nuclear power, heavy water is a powerful tool for scientists. In a lab, it can be used for things like nuclear magnetic resonance spectroscopy, or NMR, a technique that helps scientists study the structure of molecules. Since heavy water's hydrogen atoms are different, it doesn't interfere with the signals they're trying to measure. It's also used in biological studies to trace metabolic processes in both plants and animals. Medical applications. Researchers are also exploring heavy water's uses in medicine. It can act as a non-invasive tracer to study metabolic rates in humans, and some studies are even looking at its potential to help with drug development and cancer research. Now, you might be wondering, can I drink it? In small amounts, it's generally safe, but drinking a large amount, like a whole glass, isn't a good idea. Your body is used to regular water, and replacing too much of it with heavy water can disrupt your cellular processes. Simply, you're cooked. So, for now, let's just stick to H2O. Heavy water might not be a common topic, but it's an incredible example of how a tiny change in an atom can have huge impact on science and technology.